Hey, what's up? This is Justin with Lesser Dog Tutorials, and today we'll be talking about object pools in Unreal. So what is an object pool? An object pool is a set of initialized objects that are kept ready to use, as opposed to allocating and destroying them on demand. So an example of that would be if you shoot a gun and it creates a bullet hole, instead of creating the bullet holes each time you click, like this is doing, we will have a set number of bullet holes that we can hide and unhide on demand, as opposed to creating and destroying them over and over again. And this is typically helpful when you want to control the amount of objects in your game at any given time. So let's get started with that. So first we're going to create a new C++ class, and this is going to be of the type actor. So with this actor selected, we can head over and we'll just call this pooled object, and we can create that class. And then while we're at it, we want to create another class, an actor component, and we'll call this object pool. So start things off by deleting everything except for the constructor in the pooled object header file. So what we're going to add is just a few functions up here in the public section, and then a few variables down here protected. And for the public section, the functions we're going to add are setActive, which will pass in a bool called isActive, and that will set this bool active or inactive. And then we'll add a setLifespan, which passes in a float called lifetime. And what this will do is set the lifespan value to whatever we pass in. And then we'll have a function called setPoolIndex, passing in an integer called index, which will set poolIndex. And then we'll have a function called isActive that returns a bool that just returns the value of this variable. And then another function that returns an integer called getPoolIndex, which will just return the poolIndex integer. Next, we're going to add an fTimer handle that we're going to call lifespanTimer, and this will be the timer that we set with a length of lifetime. And lastly, up here at the top above the U class, I added a macro called declareDynamicMulticastDelegate1param. And what that does is just creates a delegate where we can pass in one parameter. And in our case, we're going to name this delegate fOnPooledObjectDespawn, because we want to be able to tell the object pool when this object has despawned. And then we are passing in a pooled object called PoolActor. And then down here, in the public section, I just made a fOnPooledObjectDespawn variable, and I named that onPooledObjectDespawn. And then I just created another function called deactivate that we'll be calling whenever the lifespan timer runs out. And this I made a U function that's blueprint callable, and I added it to a category called pooled object. And it's blueprint callable because I want to be able to deactivate this on my own if I want to in blueprints. And over in the pooled object CPP file, all I did was implement each of the functions that can be found in the header file, and then I cleaned up the constructor to have nothing inside of it. So next, what I did was I returned poolIndex in the getPoolIndex function, I returned active in the isActive function, and I set poolIndex equal to index in the setPoolIndex, and then for setLifespan, I just set the lifespan variable equal to the lifetime float that we passed in. Next, in the setActive function, I set the active variable to be equal to the bool that we pass in, the isActive bool. And then I set the actor hidden in game, and I use the inverse of isActive. So if we were to set active equal to true, then when it says set actor hidden in game, we want to say false. So the inverse of the bool that we pass in. And then I use the getWorldTimerManager function, which gets the setTimer function. So we set a timer that we're going to set specifically the lifespan timer variable that we made. And then we pass in this because we want to run the deactivate function. So an end symbol and then a pooled object, this class, 2 colons, and then deactivate. So it's going to run this deactivate function when the lifespan ends. So the lifespan, whatever we pass in, and then false, I believe, is for looping or not. And then for the deactivate function, it will set this active to false. It will get the world timer manager and clear all timers for object, passing in this. And then we will run the delegate on pooled object despawn and broadcast it, passing this through. For the object pool header, we want to start with something that looks like this, where BeginPlay has an override in the protected section, and then we have the constructor in the public section, and that's all. Then we'll want to make sure that we include the pooled object header. Next, we're going to add a U function in the public section that is going to return a pooled object called Despawn Pooled Object. And then we make sure that it's blueprint callable, because then it can be used as a node in blueprints, and we'll put it in a category called Object Pool. Next, we'll add 3 properties that we can see in the class defaults. The first one being a subclass of a pooled object that we're going to call Pooled Object Subclass, meaning it's only going to look for blueprints that inherit from a pooled object. And then we're going to create an integer called pool size and initialize it at 20. And then we're going to create a float called pooled object lifespan and initialize that at 0. And these will be in the class defaults of the blueprints that we based off of this. And that's why we have the edit anywhere. It can be edited in the actual editor itself. And then we'll just group them into a category called object pool. Next, we're going to add a couple of T-array variables down in the protected section. So the first one will be a T-array of A pooled objects with the asterisk for pointers, and it will be called object pool. And then we're going to create a T-array of an integer called spawned pool indexes. And this will keep track of what each pooled object's index is when it has been added to the object pool, so that we know specifically which object we're referring to. And then lastly, in the public section, we are going to create a function, and be sure to put U function up here, because for some reason this delegate situation doesn't work too well unless you have this. I don't know why, but it just doesn't. So the U function, and then we're going to call this function on pooled object despawn, passing in a pooled object called Pool Actor. Then over in the ObjectPoolcpp file, I've just implemented the 3 functions that we'll be using plus the constructor up here. So we'll have that BeginPlay, which we're overriding. So we got to make sure that we say super BeginPlay so it uses all of the BeginPlays on the parents. And then we have the SpawnPooledObject function that returns a pooled object. And lastly, we have that onPooledObjectDespawn function that passes in the pooled object that is going to be bound to the delegate on the pooled object. So the first thing we'll do in the BeginPlay function is first check if our pooled object subclass is not equal to a null pointer, meaning do we have the class assigned in which we will pull pooled objects from. Next, we want to get the world. So we want to assign getWorld to a variable. So we'll make a variable called uWorld with an asterisk, and we will make it a constant variable called world, and it will be equal to getWorld. And then we need to check if this is not null. So we will have that world is not equal to null pointer. Next, we want to go through the pool size. So we want to do a for loop that will start at 0. And as long as it's less than the pool size, it will increment up. And then we will create a poolable actor for each of these, meaning one for each of the entries in pool size. And what we'll be doing is assigning a temporary variable here called a pooled object with an asterisk or a pointer. And it will be called Poolable Actor, and it will be equal to the world that we got earlier. and then it points to the spawn actor function, and we're spawning a pooled object. And specifically, the one we're spawning is this pool object subclass that we defined, and we're going to spawn it at a 0 vector and a 0 rotation. And then, once we've done that, we check to see if the poolable actor is actually there or null. And if it's not null, then we can start doing some stuff with this poolable actor and prepare it for object pooling. So now that we've gotten the pooled object subclass, we've gotten the world, we've created the poolable actor, and all of these things are there and they're not null, then we could do a few functions, like for instance, first we'll set this actor to false so that it's not active. And then we'll set its pool index equal to I. So if we're going through the pool size, each one is going to be incremented. So the first one will be 0, the next one will be 1, and so on. And then we're going to take the poolable actor, and point to the onPooled object despawn delegate that we made. And what that's going to do is we're going to do a .add dynamic, which will then bind this delegate. And we're going to bind it on this, and a function on this, and it's going to be the onPooled object despawn function, which is down here. And then lastly, we will add the poolable actor to the object pool that we made in the header file here. And that should be all that we need to do for the BeginPlay function, so I'm just going to minimize it so that we don't need to see it anymore, and we can finish these other two things here. So for the spawn pooled object, which returns a pool object, above the return null pointer, which this will happen if nothing above it works, it will return null. But so above that, we want to do a for loop, and we're going to go through. This is actually a for each loop instead of that for loop that we saw earlier. So what a for each loop does is it just goes through your array, and it just gets each entry as a specific type. So in this case, we're doing a for each, and we're looking for a pooled object with a pointer, and we're calling it poolable actor, and then the colon is just saying, what array are we going through, and we're going through the object pool. So if the object pool was not a pooled object array, it would not ever return. All these would be null. So then we say if this poolable actor is not null, and this poolable actor is not active, so we put that exclamation point at the beginning here just to say that this would be false. So if it's not active, that means we can use it. It's ready to be used. So we do a few different things here to spawn it into, or not spawn it, but show it in the game. So the first thing we do is we take that poolable actor and we point to a teleport to function, and we just teleport it to 0 vector and a 0 rotation. And then we set the lifespan, and that's the function that we made. And we set it to the pooled object lifespan, and that's going to be set right here. It's going to be set in the editor in the class defaults. So you can set it to whatever you want. And then we will set this poolable actor to active. So now it will be visible at the location of 0. So you'll need to set this location in your blueprints. Otherwise, it will just spawn in 0 vector and 0 rotation. And then we will add to the spawned pool indexes, which is just the integer array, we're going to add its pool index. And remember, we assigned those pool indexes here on BeginPlay set to I, so it would iterate through as high as your pool size. So now we added the spawned pool index, we added the get pool index, or the index of the poolable actor, to the spawn pool indexes, which it will keep a list of which one has been added going up. And what's cool about T-arrays is that they will resize accordingly. So if we were to pull out any object from this array, it would shrink the array down and everything would move down and fill in the empty slots. So we're basically just keeping track of what object is spawned and active in the world based on a pool index number. And then we will return the poolable actor because the function needs to return a pooled object. And so when this becomes a node in a blueprint, then the right side will return this poolable actor, and we can do whatever we want with it, like set its position or anything really. Now we need to determine what happens if every single poolable actor in the object pool is currently active. If that's the case, none of this will trigger, and then we won't have anything to mess with. So what we need to do is pull out from the active items which one was activated first, and then hide it, and then respawn it to a different position that we choose. So it will recycle the oldest spawned or active actor that we created. So we will do a check to say if spawnPoolIndexes.num, meaning the amount in the array, is greater than 0, then we can decide what to do next. So if that's the case, and the spawned pool indexes is greater than 0, its number is greater than 0, then we're going to declare a temporary integer called pooled_object_index and set it to the spawned pool indexes entry number 0, so the first entry in this array. We're grabbing that because that's going to be the oldest pooled object in the scene. And then we're going to remove this integer from the spawned pool indexes because it's no longer going to be considered to be active. And then we're going to create a temporary pooled object called Poolable Actor, and it will be equal to the object pool using the index of the pool index that we assigned to the object, meaning it's an easy way for us to determine where in the object pool this object is that we're removing from the scene. Once we have that actual poolable actor, we now can set it active to false so that it's hidden. Then we'll teleport it to the 0 location to reset it. We'll set the lifespan to its new lifespan. We'll set it active, and then we will add it to the spawned pool indexes. And all this is basically what we did up here when we found one that was inactive. We're just making this entry, the oldest pooled object, to be set to inactive before we do everything we did before. And then finally, in the onPooledObjectDespawn function that is assigned to the delegate, we're going to remove the pool index of the pool actor that we pass in from the spawned pool indexes array. And that should do it for everything that we need for the object pool. So let's test it out and see if we can get it working. So back in the editor, if I look at my bullet hole blueprint class, and that's the class, the actor class that's being spawned on the wall when I shoot, I want this to have a parent class not of actor, but of pooled object. So I think what I'm going to do is create a blueprint based on my pooled object C++ class. So if you just right click that and you say create blueprint class, we can just put it in the correct location, and we'll just call it BP pooled object. And now that that's been created, we can go to the bullet hole and we will look for that pooled object, BP pooled object, and it will now inherit from that. And so that's the first step. And the second one would be that we open our character, and at the spot where I'm spawning this blue or this bullet hole actor, we're not going to use that anymore. Instead, we're going to, in the hierarchy up here, we're just going to add our object pool component. And now that it's been added, we can check out these class defaults over here under object pool. And so the pooled objects subclass, we're going to choose the bullet hole because it inherits from the pooled object, from this right here. Pool size, why don't we say 5? And the lifespan, I think for now, we'll keep it at 0. And so what we want to do, if you recall, we had a few functions here worth checking out. In the object pool, we have this spawned pooled object function. And since it's blueprint callable, we should be able to call that. So if we bring out the object pool, pull that out, spawn pooled object, and there it is. And so instead of going to this, we're just going to go to the spawn pooled object. And then the return value is the actual pooled object, right? So from there, we can set the location. And the location can be equal to the impact point here, the hit result, the same thing we were doing up here. And then we can also set rotation. Put that right there. And the rotation will be equal to this rotation. And we don't need that anymore. So now that we have the actor location and rotation set up, we can test it out and see what happens when we shoot the wall. So we've created one. As you can see, it's still there. It shouldn't go away. And if we keep shooting, you can see each time I go beyond 5, it removes the one before. And it's never adding new ones. So if we were to eject, you can see we have these 5 bullet holes here. Back in the game, we're still shooting. It's never removing or adding any of them. So with that done, we can go in here again to the object pool. And why don't we say the lifespan will be 2 seconds. Back in here, we'll hit play. And if you shoot once, after 2 seconds, it disappears. And then it still will remove the oldest, even when you're shooting. But if you just stop shooting, they'll just go away. And so now we've devised a system that will only reuse assets and not destroy and create them over and over again. And that's going to do it for this tutorial. Thank you for watching. I hope you learned something. And be sure to like and subscribe. And I'll see you in the next video.